So for this SPL, I chose to talk about grid computing. And the reason I chose about grid computing is because I thought it was really interesting that there are so many uh, projects that use grid computing for solving real world problems. And I want to just, learn a little bit more about how grid computing, something that can be applied to like any problem, can be used for something. Well, I chose this example. Fighting against childhood cancer, and how that project was by grid computing, and how it was able to run those jobs and be able to store all that data so that he could make a difference for it could make advances for fighting cancer. And there are other projects, but I thought that one was most interesting. But let's just get to what grid computing is. So what is grid computing? Grid computing is using resources of many separate computers connected by a server to solve a complex problem. And what are the benefits of grid computing? So grid computing reduces the cost of other associated hardware and software. So it's just the grid computation itself. It doesn't need anything like from outside the computers and its server to run its tasks. It achieves reliability, availability, and scalability. And the environment in grid computing is more modular, which means, and it does not have a single point of failure. So which means if a server or a desktop were to fail, then that would mean that there's another resource that will be able to cover for that failure, and then it will restart again, and so it will cover for that failure. And it's just not like the task isn't just totally stopped. And it runs jobs by splitting it into smaller chunks and then concurrently on many nodes, so that it is able to evenly distribute its jobs in grid computing instead of just relying on one heavy source to just have everything run its tasks. And it overall makes it more efficient. And like I said earlier, my example was help fight childhood cancer. And in this project, which was executed by World Community Grid, and it consisted of 200,000 volunteers who were screened for over 3 million potential drug compounds to fight against neuroblastoma, which is a tumor made of embryonic cells. And out of that project, they were able to get 7 drug candidates that were to fight against neuroblastoma. So if it wasn't for grid computing, we wouldn't be able to solve these real-world problems that affect millions of lives and could potentially find a cure for cancer. And this all wouldn't be going on, and this development wouldn't be done if it wasn't for grid computing.